Welcome to CE 3305. This is lesson 3, and the topics are intensive and extensive properties, and hopefully we get to the concept of viscosity. We're now in chapter 2, fluid properties, and in chapter 2 it explicitly states what a property is. It's a measurable characteristic of a system that depends only on the conditions within the system. Think of our ideal gas law, which is an equation of state, and the equation of state describes the property of gas, such as its temperature, its pressure, and so forth. We're going to also be introducing the idea of a system boundary, and then the surroundings on the system that influence its behavior. So let's first start with mass and weight. Mass density, usual symbol is rho, is the ratio of mass to volume at a given point. And recall from our earlier discussion, that point is actually based on a limiting condition of an elementary volume. A related property is the specific weight. The specific weight is the ratio of weight to volume at a point, and the specific weight is related to the mass density through the formula gamma equals rho g. A couple of values are provided for water at standard temperature and pressure. There's other values presented in tables in the back of the book. Next concept is specific gravity, and by definition, the specific gravity is the ratio of the density of material to the density of water at a reference temperature of 4 degrees Celsius. So for example, if the material is water at 4 degrees Celsius relative to water at 4 degrees Celsius, the specific gravity would have a numerical value of 1. Alternatively, something like mercury, which is liquid at standard temperature and pressure, has quite a bit more mass per unit volume than an equivalent volume of water, and its specific gravity would be stated as 13.6, or it's 13.6 times the density that 1 unit of mercury has compared to the same volume unit of water. Now, recall our scuba diver a few seconds ago, where they had the idea of a system and a boundary. And let's keep that in mind as we define extensive and intensive properties. Now, they're each relating the same kind of information, but an extensive property is for an entire system, and it's associated with a defined quantity of mass. An intensive property is based on system components. And these properties are related to a boundary in space. As an example, weight is an extensive property. Specific weight, which is weight unit volume is an intensive property. We'll run a little example in a second to illustrate those terms. Extensive properties relate to an entire system, an entire defined quantity of mass. Intensive properties relate to the components of a system at a representative elementary volume in space. So we're going to use a gallon of water as an example, and these are going to be based on an example on page 28 and 29. Oh, basically that's what we're reading from. Okay, so let's visualize, if you will, a gallon of water. So here's our gallon jug. Almost 4 liters of water for those of you that don't work in the world of gallons. And properly labeled as dihydrogen oxide, lab safety warning label here. And we got some blue, green, and red. Oh my. I don't have yellow, otherwise I'd put a yellow there too. Okay, and we put that on a scale. There's my scale, and that scale reads out in pounds force, 0, and then the meter goes to 8.3. You can use digital scale. And now from this volume of water, I'm going to take 30 cc's. About 1 ounce of avoirdupois. Let me put it on a scale. So now we have a different scale. We put our little 30 cc bit of water here. And this time, the identical scale reads 0.065 pounds force. All right, what we have here, on the left side, we've discovered that 1 gallon weighs about 8.3 pounds force, and we have 30 cc's weighs about 0.065 pounds force. So we're going to consider the gallon is the entire system. That's the extensive component. And we're going to examine how the intensive property, the 30 cc's, is related to the entire gallon. Okay, so now let's compute the specific weight of a gallon. We know that gamma of the gallon equals 8.3 pounds force per 1 gallon. And gamma of the 30 cc's is 0.0651 pounds force per 30 cubic centimeters. And we happen to know that 30 cubic centimeters is about 1 ounce of volume. And we know there's 128 ounces in 1 gallon. When we perform this arithmetic indicated here, we come up with a whopping 8.32 pounds force per gallon versus 8.31 pounds force per gallon. For all practical purposes, those are identical. The specific weight is the same regardless of the volume, at least as long as we're in the REV world. And that is the definition of an intensive property. So the intensive property of specific weight is 8.31 pounds force per gallon. And that is the relationship between intensive and extensive. Once we know the number of gallons of interest, we can easily go from an intensive property to recover the extensive property of the system. So if the system is indeed the entire gallon, then we multiply the 8.31 pounds per gallon times the entire gallon to recover the extensive property of 8.31 pounds. If, on the other hand, the volume of interest is only 30 cc's, we would perform similar arithmetic and recover 0.0651 pounds force for the entire system, which in that case would be the 30 cc system. So that's the relationship between intensive and extensive properties.